Hi class, today we're doing Bluebook 3.4 Extra Practice A, okay, and we're going to take a look. I'm doing even numbers with you. On the first two problems, it says describe a real life problem that has the given rate and intercept. Draw a line that represents the problem. So let's take a look at it. Here we have a situation where the rate is -3. So that's the rate of change, -3. This is number 2. All right, and the -3 per day. And the y-intercept is 27, okay? And then it says that the x, so the y is 27, okay? This is the rate, and the x is 9, okay? So let's take a look at it. If x is 9, and y is 27, the change is 3. We're going to count by 3. So 1 3, 2 3, 4 3s, 5 3s, 1 2 3 4 5 6 7 8 9 3s would be 27. So that's going to be our starting point, okay? And so what it's asking us for a real life problem. So what is happening is per day, according to this, we lose 3 trees, okay? So let's think of it. Okay, it's a holiday time, Christmas time, trees, Christmas trees. Let's say you are selling Christmas trees, okay? And so you have X number of Christmas trees to sell. So then how many Christmas trees do you have to sell? Well, the y-intercept gives us our starting point. That's how many we have to sell. And each day we sell, we decrease, all right? Until we have no more Christmas trees, right? So let's see. We start here, and on our y-intercept, we have 27, okay? So we start with 27 trees, and each day we drop 3 trees, 3 trees, 3 trees, 3 trees, okay? And so, because remember, we're counting by 3s here. So each day we drop 3 trees. And as we are dropping 3 trees, we discovered that we eventually do what? Run out of trees. How long did it take us to run out of trees? These are our days. It took us 9 days to run out of trees. So if we started with 27 trees, in 9 days, if we're selling 3 trees a day, we have no more trees. And that is my real life example for this particular problem, okay? Next, let's look at number 4. Okay, so we are selling Christmas trees. 3 trees per day. Started with 27 trees. All right, and after 9 days, they are all gone. All right, that's our story. Oops, that's our story. That's my story, and I'm sticking to it. Okay, moving forward. Let's look at number 4. Number 4 says, you are cooling water for a science experiment. The graph relates the temperature in Y degrees. Okay, so they counted by 15. So this was 15, 30, 45, 60, 75. So here we are right here, counting by 15. Okay, 5 times 15 is 75. So we're going to put 75, this is 60, 45, 30, and this is 15, okay, for the sake of our graph. All right, so now down here they're doing the same, 15, 30, so on and so forth, counted by 15. So we start here at 0.75. That's our starting point, 0.75. Okay, now then we stop here at 45, okay, 15, 30, 45, all right? Here's our ending. Here's our starting point for cooling this water. Okay? So now it says the graph relates the temperature y in degrees. So this is our degrees. And the cooling minutes x. Okay? Now, A, interpret the x. So if we're cooling the water, when we get here, all right, for our x, that's where we have stopped. All right, at 45 minutes, our water is cool. All right, that's our x. X is at 45. The water is cool or at 0 degrees. Okay, now, next it says our y-intercept. Our y-intercept is equal to 75. That's the beginning temperature. Okay? All right, now, B. What is the slope? Okay, so for B, we want to know what the slope is. So then, let's see. In this case, we are falling 3, running 1, right? Because at the rate we're going, we need to find our slope. Let's see. If we at 0.75, and then at 45, 0, right? Okay. Let's find our slope. Y1 minus Y2, X1 minus X2. All right, and we will find that in this case, we can do this 1, 2, 3, 4, 5. Okay, from here, that we went 75. Okay, from here, which would give us 75 over our run would be 1, 2, 3, 45. Here we divide both by 5. And we discover that in this case, we have how many 5s are in 75? We get a 15. How many 5s are in 45? We get a 3. Can you see that? Let me bring that over here. We discovered that it's 75 from here up over 45. Okay, our run, right? And we decided to simplify it by dividing by 5. And we get a 15 over 3. I'm sorry, 15 over 9. Okay? And so then we need to simplify that by 3, divide that by 3, divide that by 3, and we get a 5 over 3. Okay? Now, we went up and we went to the left, so that makes it negative. Okay? So we have a negative 5/3. That's our slope. Sorry for the mess. Negative 5/3 is our slope. Okay? What does the slope represent in this situation? Well, the slope represents in this situation our rise, which is our y. Our y is actually our temperature. Okay? And this is our time, okay? So the y, we're dropping 5 degrees for every what? 3 minutes, okay? And so that's what happens. That's how we interpret that. We drop 5 degrees. We drop 5 degrees for every 3 minutes, okay? All right, so that's what we discovered. So now let's look at C. And C says, what is the equation of the line? Well, then if this is our slope, and then this is our y-intercept, that's the equation of the line. Then D says, what is the temperature of the water? When is the temperature of the water 55 degrees? Well, in order to know that, we would have to plug 55 degrees in. Well, we want to know where when it's at 55, when y is 55, what is x? That's what, in essence, what it is saying. So in our equation, I need a little more room, little more room. in our equation, y is equal to negative 5/3 x plus 75, when y is 55 equals negative 5/3 x plus 75. That's what it's asking us to do. All right, to find out what x is when y is 55. So we take 75 from both sides. All right, plus 75 on both sides, and we discover that on this side we have actually 20, negative 20 is equal to a negative 5/3 x. And so therefore, to get rid of this, we're going to reciprocate 3 over 5 negative, and we would do it over here, 3 over 5, and that's negative, okay? And this will be over 1, and we discover that x will be equal to 12. Okay, so x is 12. So in 12 minutes, the temperature of the water will be 55 degrees. That's what D is. D is 12 minutes. Okay, now the next question is asked. Water freezes at 32 degrees Fahrenheit. After how many minutes is the water frozen? So now, if the temperature is 32, okay, then we need to know the minutes. We don't know the minutes, so we do the same thing, but this time we put in 32 degrees. So let's go. We're going to do this. We're going to use our slope, our equation, y equals negative 5/3 x plus 75, and it asks us after how many minutes is the water frozen if the water freezes at 32. So we're going to put a 32 here, because that's what the temperature is. Y represents the temperature. So if it's at 32, negative 5/3 x plus 75. All right, so then we're going to plus a negative 75 here, plus a negative 75 here. And we discover 5 minus 32 is 3. 5 minus 2 is 7 minus 2 is 43. It's negative, and then we're going to do the same thing as we did before. We're going to reciprocate here, and we're going to discover that x is, in this case, we're going to have here 3 times this is 9, 129 over 5 equals x, and then we're going to need to simplify that by taking our 129 and dividing it by 5. $129 divided by 5, and we discover that x is equal to 25.8. Okay, because we need, it's not a fractional representation of the time, but an actual a number including decimals. Okay, and so therefore that is section 3.4. Okay, bye. See you in the morning.